Okay, we have something a little bit different today. We've got the sum from n equals 4 to infinity of 1 over n squared minus 5n plus 6. Okay, to start with, the first thing I want to notice just here is this lower bound here, n equals 4. And the thing to notice is we usually start at a value like 0 or 1. But here, if we did that, there's a few different points where we're going to be dividing by 0, and that's going to cause a problem. Now, to get started with this, I just want to notice that this here, this whole thing is just a factorable. So what we'll do is let's just rewrite this. And how I can factor this, I can factor this as n minus 3 times n minus 2. And now from here, what I want to do is I want to try to break this up. What we could do on this is partial fractions. We could use the cover-up method, but I kind of like to avoid it if I can. It's not going to save a lot of time, but what I like to do is for this 1, what I can do is I can rewrite that using what we have in the denominator. So I can just create an expression for 1 by taking n minus 2 and then subtracting n minus 3. Then if you just subtract these, you'll notice the value is the same as 1. If it came out to something else, if it came out to like 3, well, we could just divide by 3 out front, so we could still use this trick. But then doing it this way, what's going to happen is we're going to get some nice cancellation when we separate this out. So what I can do now is actually take this and break this into 2 fractions. I can write this as n minus 2 over this stuff. And then for our second one, we're going to have this minus in front, and then we'll have this n minus 3 over the same denominator. But then I can cancel n minus 2's here, n minus 3's here, and then we just have 1's in the numerator. And now you may already recognize this as a telescoping series, but let's just write out a few terms and kind of see what's happening. And so again, we're starting at n equals 4 here, so just plugging in 4 here. For our first term, we have 1 over 1. I'll just leave it like that. And then here, this term is going to become minus 1 over 2. And then looking when n equals 5, this is going to become 1 over 2. And this one's going to become minus 1 over 3. And then we'll just do a couple more really quick. So we'll have 1/3 minus 1/4. And it doesn't take very long to see the pattern here of what's going on. So we'll just write a few more. And then when you write everything out like this, it becomes clear that we're going to get all kinds of cancellation, because right here we have 1/2 minus 1/2. We have 1/3 minus 1/3, 1/4 minus 1/4, and so on and so on. This is going to go on all the way to the end. Now we will have a term left over here at the end, but the thing about it is, because our series is going to infinity, we can look at this as a limit right here. If you look at this as a limit as n is going to infinity, then this piece here is 0, and then we're not worried about this piece either. So what's going to happen here is all of our terms are gone. We're just left with this first term, this 1 over 1. And so what we can say is for our solution of this series, the value is just going to be 1. Now, one thing to look out for, the cancellation won't always be this clean. Sometimes the terms won't be right next to each other, and you'll have to kind of like look 2 or 3 terms down. Also, an important thing is notice that we have a minus sign here. Sometimes if your factoring works out a different way and this is a plus sign, well, then you actually don't have a telescoping series. You probably have something that diverges or something with a different case. So that's it. There you have a quick example with the telescoping series. Thanks everyone for watching. Have a good day.